So let's think about what Hagai just told us. A few things. We are seeing blockchain becoming more and more involved in multiple domains like election, smart contracts, about the fintech we don't need to mention, everybody knows about that. And he said that there will be a lot of new jobs specifically for blockchain implementation. So companies are going to look for experts in the blockchain domain. So think about that. Maybe you should, developing your career into the future is to concentrate on blockchain implementation. And by the way, do you know, for example, which word, I think you know the answer, but let me put it. If you check today at Google, which word is more searchable, IoT or blockchain? You know, this is why you are here. Blockchain passed the IoT search word in Google. So with that, let me now introduce you to Eli Ben Sasson. So Eli Ben Sasson will present today the academia part of this panel, this keynotes. And Professor Eli Ben Sasson is a professor at the Technion here in Israel. He got his PhD from the Hebrew University in 2001. He is a research position at MIT and Harvard. And also, Eli is standing behind and a co-founder for a startup which have their own cryptocurrency called Zcash. So let's welcome Professor Eli Ben Sasson.
Okay, thank you very much for inviting me. I'll talk today about Zcash and some cryptographic techniques called snarks and starks. So first I want to explain what I now understand is the key innovation of Bitcoin. So at first people used money as some form of limited physical resource, limited by nature like gold or seashells. Later on fiat in Latin means it shall be. So a limited resource made by a central trusted party like a central bank or a king was used and trusted by people. And now we have Bitcoin and other cryptocurrencies that say in crypto we trust. And the supply of coins is limited by consensus. There's no central trusted party. And this is really, really the most amazing part about Bitcoin. It's not the particular consensus protocol or the use of cryptography. It is the fact that for the first time in the history of the human people, a societal function, namely money, that we thought requires a central trusted party, now suddenly doesn't. And of course, you could ask what other social functions could be replaced next by such protocols or by some other protocols, maybe law, corporations, government, academia, religion. These all are things that right now rely on trusted parties. Now, once you remove the trusted party with the ability to regulate it or even know who is exactly right now, let's say, the head of the Israel central bank, you face a new problem, which is the one of computational integrity. And stated simply, it is the following problem. How can the public trust the output of a computation? So in the case when we have humans or central organizations doing it, so there's legislation and regulation and auditors and accountants and lawyers and people that look at it. But now we don't have any of those. It's a completely decentralized network. All we have is algorithms, cryptography, and math. And often the party that runs the computation has an incentive to misreport the output. When I report my taxes, all things considered, I would like my tax due to be zero or maybe even to be owed money back. It is my incentive as a rational agent. The same thing when you look at claim settlements or forensics. And even if the party that's executing the computation is agnostic to the outcome, some other party may corrupt it and pay money or do something else to get the output it requires. So this is a big problem. Now, Bitcoin's solution is straightforward, and it works. It asks everyone to provide enough information on the blockchain that stays forever for everyone else to see that computational integrity is indeed maintained. And that works. But of course, it creates a new problem, that of financial privacy. So really the problem that interests me as a researcher is how can the public come to trust the output of a computation while still preserving privacy things like financial privacy. And it seems that these two things contradict each other. But actually, there is a beautiful set of tools that was first invented in the mid-1980s, things called cryptographic proofs, interactive proofs, and various other names, zero-knowledge proofs. These concepts already won many prizes within the research world, such as the 93 Gödel Prize and the Turing Award in 2012 to Goldwasser and Micali for the invention of zero-knowledge proofs. The Turing Award is the analog of the Nobel Prize in computer science. And these things have been cited and studied in thousands of research papers. But only recently, we started seeing implementations of them. And getting the theory to practice of such marvelous proofs is what I'm passionate about. So what exactly are these cryptographic proofs? And here I'll give a very high-level description that actually omits a lot of things, but okay. You can read more about them, and it has some beautiful math and cryptography. So from a functional point of view, the function that these zero-knowledge or cryptographic proofs serve is very similar to the function that a grocery receipt serves. So what is a grocery receipt? It's just a string of characters, usually printed, but you could also get it today by email. And it's something that both parties, the grocery store and the customer, know that it enforces computational integrity with respect to summing up and computing the total, right? We use it so that we know that we should pay what's written in the total. And the way this proof works is that we know how to sum things up, so we can recalculate the sum and derive the result. But the essence of what this grocery receipt does or achieves is a proof of computational integrity by naive re-execution, because we can re-execute the computation. Okay, so cryptographic proofs are pretty much the same, but first of all, they have this magical property called zero knowledge, which means that when you see a proof, when you see the string of characters that's in this new kind of receipt, you learn nothing about auxiliary inputs that went into the computation, things like passwords, financial, medical data. You only learn what you can surmise from the statement being proved. For instance, if I would prove to you, using a zero-knowledge proof, that I control more than 1,000 bitcoins, which I don't, you would not know which coins these are, and you would not know how much more than 1,000 coins I have. You would only know what you can learn from the statement that I just said. That's the nature of zero-knowledge proof. These zero-knowledge proofs are also universal or Turing complete, which means you can apply them to any computation, not just to summing up the items on a grocery receipt. Okay? And the last thing is that these proofs can be made scalable, which means they are very efficient, and there's a concise mathematical explanation that now this will be the deepest math that I'll present here. So if t is the number of cycles that your processor would take to execute the computation without any proofs, then actually the time needed to verify the computation behaves roughly like the logarithm of t, which is much, much smaller than t, okay? So for t cycles, verifying the proof would take much less than t cycles. And the proof would be much shorter than t characters. And the time needed to generate such a proof is also scalable, which means it behaves like t times logarithm of t. So I just gave here some numbers of what do these two measures mean. So for instance, for 1 million time steps, the log of t, even if when you square it, is roughly 400 steps, which is much smaller than 1 million, and t log t means 400 times 1 million. And even when you go up to something like 2 to the 30 cycles, which is 1 tera, 1,000 billion, the log of t squared is only 1,600, okay? So you get efficiency that's very extreme for verifying. To generate the proof, the prover needs to work a little bit harder. This grocery store would need to work harder, but now everyone can verify it very efficiently. So how did I come to fall in love with cryptocurrencies? I'm a professor at Technion, and I studied for a long time theoretical computer science focusing on the mathematics behind efficient cryptographic proofs, what Vitalik Buterin from Ethereum coined as moon math, the analog of rocket science. And in 2008, I started actually working on implementing some of these proofs. But it took 5 years and more work for me to reach this eureka moment that I understood that actually decentralized cryptocurrencies are the thing that needs these magical proofs. And before that, we went around and said to people in standard business, we have these zero-knowledge proofs, they're really cool. What do you do with them? And they would ask, okay, why do you need it? Are you sure 1 minute? I mean, I have here 9 minutes, so, okay. Okay, I'll try to continue, but, okay, I'll try to wrap it up, but, okay, so they would ask, what's a zero-knowledge proof? Why do you need it? And when you talk to people in the decentralized cryptocurrency world, their answer is different. They don't ask what it is, they ask, okay, where's the code? How can we use it? And that's been the case since then. So we wrote a paper describing a new kind of cryptocurrency that has much higher level of security and privacy. And then we co-founded a company along with my co-authors on that paper. So I won't explain how it works, but you can read on the website of Zcash, you can see how it works. Okay, here's just an hour ago I sort of uploaded some data about about the financial data about Zcash as a cryptocurrency. Most of the stuff that's going there I don't know to explain, including why the price dropped like last day. The only thing I know to explain that is on the 22nd of May, Zcash announced a partnership with JP Morgan Chase, interested in implementing the zero-knowledge proofs on their own stuff, and that caused a big jump. That's the only thing I can explain. Now, what I've been up to more recently is, those of you who are familiar with this technology will know that actually it has some disadvantages. It requires a trusted setup phase that cannot be made transparent. And if someone can compromise this trusted setup phase, they can use it to forge money. And also, these techniques are not quantum secure. A quantum computer could break them. So what we have is a new system that we already wrote the code, and we pretty much wrote the proofs, but now we need to finish writing up the paper. We call it a Stark. And it already appears, for instance, it was mentioned earlier, the R3 paper, which uses Intel's SGX technology, but they also acknowledge that ZK Starks, if they ever come out, could be an interesting alternative. So S is for scalable, T is for transparent, meaning there's no trusted setup whatsoever, and it's also post-quantum secure. And I just want to say that transparency and not relying on any trapdoors, neither inside SGX or other things, is very important for ongoing public trust. So I wanted to show you some numbers. Do I have time to show, or I should? Okay, so here's an example. The FBI holds something called a CODIS format DNA profile database. And each profile is 20 sets of pairs of integers. So what we did is we ran our program for proving for the FBI, or an FBI-like organization, to prove in zero knowledge that the output of a DNA search match is correct. And here are some numbers. We ran it up to a database with 1 million entries. That's a 40 megabyte long file. And the proofs are less than 1 megabyte long, so you have proofs also compressing the database, and it takes to verify them 40 seconds. The green stuff is the new system. When you measure it overall, it's more efficient than all previous techniques, including ZK Snarks. So in conclusion, Bitcoin's innovation is the first decentralized fiat money, no trusted party. Removing the trusted party raises the problems of privacy and integrity, and crypto proofs like the ones used in Zcash can help solve it, and ZK Starks, soon to come out, solve it even a little bit better. Two questions: which societal functions are next to fall after money? And the second is, what can ZK Starks do for you? Okay, so thank you very much.
Thank you very